Hello everyone. So today is the week 1 of DSA 441 cloud computing. So for today we are going to learn about an introduction to cloud computing, migration from physical services and their architecture comparison. So this is what we are going to learn today. So in this semester, we are having totally 15 weeks. Out of these 15 weeks, we have like 2 weeks of exam, that is the midterm exam, as well as the final exam in the 7th and the 15th weeks. And these are the topics which I am going to cover over the next weeks until the final exams. So just have a look on these topics, and the PowerPoint copy of this presentation is given in the link of this video's description. So this is how I am going to assess the students for the final exam as well as the midterm exam and as well as for the whole of the semester. So before going into the cloud computing, we need to know about the basis of software development life cycle. So those who have not taken any course about the software development life cycle, so this is a short video which can make you to understand. Just let me play this video.
Welcome to LearnComputerScienceOnline.com, and in this video, we are going to discuss what is software development life cycle. The software industry is one of the largest industry that employs large number of computer science professionals. A software is a type of computer program that has been designed and developed that provides solution to a specific problem. The software is also alternately referred as software package. However, developing any software is not easy, and the software design team has to plan and execute many activities to achieve the desired results. The software development life cycle is the process used in the software industry to design and develop a new software. The software development life cycle defines the various steps involved in the planning and execution of any software development project. The software development project typically involves many activities and goes through different development of stages. These stages in the development process are also referred as software development life cycle phases. The software development life cycle can be broadly split into 7 phases, and this includes 1. Software planning. 2. Defining the requirements for the software. 3. Designing the software based on the requirements. 4. Building the software. 5. Software testing and validation. 6. Software deployment and installation. And finally, 7. Software maintenance. The final outcome of the software development life cycle process is the software that meets the client's requirements and the design objectives that software must achieve. Let us now discuss each of these software design phase in detail. The software design process starts with the planning process. The planning process is the most important step, which helps the software design team to plan for all the resources required to complete the project within stipulated time and resources. During the planning stage, the software development team has to plan for various activities, manpower resources, infrastructure required and other resources required to complete the project. The next phase in the software development process is referred as defining the software requirements. This process is also alternately referred to as requirement solicitation. In the requirement solicitation process, the software development team extensively interact with all the stakeholders to capture and map all the information necessary for defining the software requirements specifications. These user requirements document is abbreviated as SRS. The software developer must document this important piece of information, which is part of the agreement with the client company. After the project completion, the software performance is assessed against the SRS and agreed design objectives. The next and third phase in the software development process is referred as designing the software. The software designing phase includes finalizing the various design features in terms of both software requirements and the supporting hardware requirements. The software architects and the software developers explore the various alternative approaches, and finally, propose the product solution. The software developer design the software system and specify the technology to develop the software system. The software architect document this information about the product architecture in the design document specifications, also referred to as DDS. The next and fourth phase in the software development process is actually building the software with suitable technology and tools. After finalizing the software requirements specifications, SRS, software design features, and the software system architecture, the next step is to actually start building the software by coding. Depending upon the type of the software that is being developed, the software development team can select the technology to be used for the development of the software. The software development team can select the suitable platform, programming language, software framework, database management system, and other building tools, as specified in the software system architecture. The software building activities includes coding the various modules, debugging the program code, compiling the various software components, and testing the functionality. The next and fifth phase in the software development process is the software testing. Once the software coding task is completed and the final software product is ready for deployment, the software is subjected to rigorous and extensive testing before its final deployment and delivery to the client. The software testing is the standard process used in the software industry to test the software for its performance, accuracy of results, user experience to ensure the satisfaction of the user expectations. The software testing includes conducting comprehensive set of tests to identify the gaps, errors, deviations in the final software product. The software development team carries out the necessary corrections in the software. The software testing process aims at complete elimination of all the software bugs before its final delivery to the client. The software bugs are defects in the software that can cause malfunction of the software and damage. The next and sixth phase in the software development process is the software deployment and its successful installation. The software is considered to be ready for deployment after building the software, and it has successfully gone through all the tests to ensure bug-free software and other quality parameters. After its successful installation, the next task is to impart training to the end user. The software has to complete user acceptance trials. The last and seventh phase in the software development process is the software maintenance phase. The software maintenance phase of the SDLC starts after the software deployment process is completed and the software is fully operational. The software maintenance tasks include a number of activities such as periodic software upgrades, software patches, database cleanup operations, and resolving any other issues. That brings us to the end of this video tutorial, and in this tutorial we have discussed what is a software development life cycle and various.
So we have learned about the software engineering as a brief level. So this helps us to know about the need for cloud computing. Actually, like there are some concepts in cloud computing which can be understood with the help of the concepts mentioned in cloud computing. When we compare about cloud, without cloud there is some architecture called as on-premise. We have on-premise computing as well as the cloud computing. Cloud computing is easing up the on-premise traditional way of setup. So we are going to see what and how cloud computing is having an upper hand over these on-premise setups. So when it comes to website hosting, normally when we need to have our own website from hosting from our own computer, then we need to buy a server, and then we need to have some kind of static IP where we can access the local host or like the web hosting space from our server from anywhere in the world. But in the case of cloud computing, we don't need to buy any of these servers, so it reduces the cost. In deployment, we need to have more number of people working on maintaining the network and the server systems which are available in our organization. So in cloud computing, we don't need to have this kind of manpower, so it reduces drastically with the amount of manpower needed. So then we have the workflow and delivery. So we have this on-premise and on-cloud architectures. So in the on-premise setup, we have like everything in one particular area. So if that particular area is having some problem with the network or with the power outages, then everything is gone. But in the case of cloud computing, we can have the copies in multiple regions and multiple servers across the world. When we have the on-premise setup, it costs a lot for electricity because the servers will be running 24/7 and the cost is more. It includes even the cost of buying these equipments as well as the electricity consumed by these equipments. But in the case of cloud computing, we don't need to worry about this electricity usage and its cost. In the case of bandwidth enhancement, in case if we want to expand the servers we have, we need to go and buy for extra hardware and we need to set up more things to increase the bandwidth and many other parameters. But when we need to downgrade, it is not possible. We have to go with the extra purchased things. But in the case of cloud, you can enhance the capacity as well as you can step down the capacity as much you want. So it is like you pay only for how much ever you eat or like how much ever you consume. And in access control in on-premise setup, like we have like kind of less kind of security in the case of on-premise system, but the cloud is providing more security. So then now we are going to see how coronavirus lockdown has increased the demand for the cloud services. So this is a report from Bloomberg. So that's a news report on the demand for cloud services which are available. And now we are going to see the next concept. That is, we have a class activity already. And now we will go into the introduction to cloud computing. So before I explain what exactly the cloud computing, here this is a short video on explaining what exactly cloud computing is. So I'll just play on this video. So this will explain you about a nutshell of cloud computing.
Imagine you're the owner of a small software development firm and you want to scale your business up.
And this gives a
However,
scenario
a
based
small team
explanation.
size, the unpredictability of demand, and limited resources are roadblocks for this expansion. That's when you hear about cloud computing. But before investing money into it, you decide to draw up the differences between on-premise and cloud-based computing to make a better decision. When it comes to scalability, you pay more for an on-premise setup and get lesser options too. Once you've scaled up, it is difficult to scale down and often leads to heavy losses in terms of infrastructure and maintenance costs. Cloud computing, on the other hand, allows you to pay only for how much you use, with much easier and faster provisions for scaling up or down. Next, let's talk about server storage. On-premise systems need a lot of space for their servers, notwithstanding the power and maintenance hassles that come with them. On the other hand, cloud computing solutions are offered by cloud service providers who manage and maintain the servers, saving you both money and space. Then we have data security. On-premise systems offer less data security, thanks to a complicated combination of physical and traditional IT security measures, whereas cloud computing systems offer much better security and lets you avoid having to constantly monitor and manage security protocols. In the event that a data loss does occur, the chance for data recovery with on-premise setups are very small. In contrast, cloud computing systems have robust disaster recovery measures in place to ensure faster and easier data recovery. Finally, we have maintenance. On-premises systems also require additional teams for hardware and software maintenance, loading up the costs by a considerable degree. Cloud computing systems, on the other hand, are maintained by the cloud service providers, reducing your costs and resource allocation substantially. So now, thinking that cloud computing is a better option, you decide to take a closer look at what exactly cloud computing is. Cloud computing refers to the delivery of on-demand computing services over the internet on a pay-as-you-go basis. In simpler words, rather than managing files and services on a local storage device, you'll be doing the same over the internet in a cost-efficient manner. Cloud computing has two types of models: deployment model and service model. There are three types of deployment models: public, private, and hybrid cloud. Imagine you're traveling to work. You've got three options to choose from. 1. You have buses, which represent public clouds. In this case, the cloud infrastructure is available to the public over the internet. These are owned by cloud service providers. 2. Then you have the option of using your own car. This represents the private cloud. With the private cloud, the cloud infrastructure is exclusively operated by a single organization. This can be managed by the organization or a third party. And finally, you have the option to hail a cab. This represents the hybrid cloud. A hybrid cloud is a combination of the functionalities of both public and private clouds. Next, let's have a look at the service models. There are three major service models available: IaaS, PaaS, and SaaS. Compared to on-premise models, where you'll need to manage and maintain every component, including applications, data, virtualization, and middleware, cloud computing service models are hassle-free. IaaS refers to infrastructure as a service. It is a cloud service model where users get access to basic computing infrastructure. They are commonly used by IT administrators. If your organization requires resources like storage or virtual machines, IaaS is the model for you. You'll only have to manage the data, runtime, middleware, applications, and the OS, while the rest is handled by the cloud providers. Next, we have PaaS. PaaS, or Platform as a Service, provides cloud platforms and runtime environments for developing, testing, and managing applications. This service model enables users to deploy applications without the need to acquire, manage, and maintain the related architecture. If your organization is in need of a platform for creating software applications, PaaS is the model for you. PaaS only requires you to handle the applications and the data. The rest of the components like runtime, middleware, operating systems, servers, storage, and others are handled by the cloud service providers. And finally, we have SaaS. SaaS, or Software as a Service, involves cloud services for hosting and managing your software applications. Software and hardware requirements are satisfied by the vendors, so you don't have to manage any of those aspects of the solution. If you'd rather not worry about the hassles of owning any IT equipment, the SaaS model would be the one to go with. With SaaS, the cloud service provider handles all components of the solution required by the organization. Time for a quiz now. In which of the following deployment models are you, as the business, responsible for the application, data, and operating system? 1. IaaS. 2. PaaS. 3. SaaS. 4. IaaS and PaaS. Let us know your answer in the comment section below for a chance to win an Amazon voucher. Coming back to cloud computing, some of the most popular cloud computing services in the market are AWS or Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Want to learn more about them and how they differ from each other? Click on the top right corner for an analysis of how these service platforms are different from each other.
So that's a small introduction about cloud computing. And now we see the definition of cloud computing, which is given by the National Institute of Standards and Technology. So they mention that cloud computing is actually an environment which provides an on-demand network access, which shares a pool of resources, like resources in the sense they include the networks, servers, storage, and applications and other services. So they can be rapidly provisioned and released with a minimal management effort or service provider interaction. So this cloud model promotes the availability, and it's composed of five essential characteristics and three service model and four deployment models. So we are going to see about these characteristics, service models, and deployment models. So firstly we see about the central ideas. In the central ideas we have utility computing, SOA and SLA. SOA means it's a service oriented architecture which belongs to the Web 2.0, and SLA is the service level agreement, that is third component in cloud computing. SOA is, which I mentioned about in the Web 2.0, it has been in force since the uh, 2007 or 2008. It was taken in a huge scale by IBM, and later a lot many players in the market came to use it, and now it has transformed into this cloud, so it has a lot of potential into it. So all these three concepts get into an intersection which forms the cloud computing, and this in turn gives some properties and characteristics, that is high elasticity and scalability, high availability and reliability, high manageability and interoperability, high accessibility and portability, and then we have high performance and optimization. And these techniques are enabled using hardware virtualization, parallelized and distributed computing, and web service. So in hardware virtualization, there is a section specifically allotted in the next video, that is the week 2 video, where we will learn about how the hardware is virtualized and used for multiple virtual machines. And scalability, availability, manageability, accessibility, and performance, we will learn one by one. So this is the architectural diagram which describes about the essence of cloud computing. So it has the central idea of utility computing, service oriented architecture, and service level agreement in the center, and on top of it we have the services of scalability, elasticity, availability, reliability, performance optimization, accessibility, portability, manageability, and interoperability. So first let's see about the scalability. Scalability deals with the number of users which is allowed as the maximum to access a server. And in the case of higher traffic, if the users exceed the number of threshold set for that particular server, then the users may find difficulty in accessing that server, and the availability of that server will be limited in that case. So cloud computing increases the scalability by increasing the number of machines and the number of users who can pull into that database system in that server. So the scalability and elasticity is like a prime factor for cloud computing. And then availability and reliability. Since we are increasing the scalability, the resources are made available, and it can be given access for how many ever user come into the system, or like we maximize the potential of the number of users who can use those services when compared to the on-premise system. So what is fault tolerant system? Like there might be some kind of network issues or power issues or some kind of technical glitch which is present in the server. Fault tolerant system is the technique which manages all the faults, or like it kind of controls, or like it gives some quick fixes to tolerate these faults and go ahead with the operation, like how far it can operate, how much fault it can overcome, how it can increase the security of the system. So these are the things mentioned by the fault tolerance. So if the operational quality decreases, this decrease is proportional to the severity of the failure. So we need to increase the operating quality. And then we have the four basic characteristics, that is we should not have a single point of failure, a fault detection and isolation to a failing component, fault containment to prevent the propagation of failure, and availability of reversion modes. And then we have the parallelism, parallel processing. Parallel processing is something like uh, it's quite different from the multitasking. Like if we open like multiple softwares in the same computer, it is like multitasking, like multiple operations are happened in the same time and they all share the same processor. But in case we have like multiple processors, processor units, and they are sharing on to the process, then that is what we call it as a parallel processing. One big task has been partitioned within the processor cores available, that does the parallelism. So the parallelism is normally done at the level of task. Normally anything which is done by a computer, it is a task. We do the parallelism at the level of the task, and on top of it, what is going into the task, it is the data. So we do a parallelism at the level of the data, and then on top of the data we have the instructions are fed as data into the system. So we have the parallelism at the level of instructions. How these instructions are sent into the machine will read only the zeros and ones, so it will go in the form of bits. So we have the parallelism at the level of bits, so we call this as the bit level parallelism. Now we see about the benefits of using cloud computing for anyone who opens a company or any end user or individuals. For anyone who is having an entrepreneurship mind, want to have like an IT business or anything like that. In the earlier days with the on-premise setup, they need to go and buy a lot of computers with the latest configuration, and they need to buy a server, and they need to have an internet connection, and they need to keep a lot of cooling system for the server. So many expenditures will be there. So when we use this cloud computing, it reduces this initial investment to a lot of to a considerable level, and then because of this reduce in the initial investment, we reduce the capital expenditure. So this in turn will improve the specialization of the industry, and it will improve the utilization of resources. Like it's not like limited resources, the resources are made enormous, and we maximize the usage of those resources rather than having like on-premise setup and having a limited resource and to have some considerable amount of utilization. And for the end user and individuals, for example, if we are having a virtual machine from the cloud which has a GPU, for using that system, the user doesn't need to have a computer with a GPU. So they can use it with a computer which supports a normal browser. That is enough. So it reduces drastically the local computing power and the local storage power. You don't need to store it in the local hard disk. The data can be stored in the drive which is provided in the cloud provider. Like Google Drive is a storage provider. We can store our files into that Google Drive, and then we can access it from anywhere. And then we can have like a variety of thin client devices in our daily life, lot many devices like mobile tabs and all those things. A classic example is the iCloud, which we use for the Apple iPhone and its subsidiary products, or like some sub products like iWatch and so many other things. So this is a hype cycle which is published by Gartner. We see that cloud computing is having scope of containerless system. Container serverless architecture, we use it for like around 2 to 5 years of scope, and we have more than 5 to 10 years of scope which is given for computational storage, and then for IT or IoT hybrid servers, and some other similar things like immutable infrastructure, and quantum computing is having a huge potential. So this is the hype cycle which we see every year. This has been published by Gartner, so we can see and monitor the trend. So far I haven't seen anything related to 2021 version, so this is the latest version I have right now. And right now I would like to discuss about the top four cloud providers which are available. We have this Amazon Web Services, which is the largest as of now in the whole world, and then we have Microsoft Azure, and then we have the third largest provider is Alibaba Cloud. Alibaba Cloud has been in the market for the last few years, and they have been improving to a greater extent outside of China, and they have become like the number one cloud provider in Asia, and they are like the third largest cloud provider in the whole world. And Google Cloud is the fourth one. These cloud providers are primarily used by many software business systems, and many people who avail the cloud systems. So when we understand about cloud computing, we need to understand about the users and providers of cloud computing. So on bottom we have the cloud provider, someone like Alibaba Cloud or AWS or Azure. They provide the utility computing, which they mention as the SaaS provider or the cloud user. And on top of this SaaS provider, we install the web applications. So this web application is being accessed by the SaaS user or the end user. So the end user is the SaaS user or software as a service. And then we have the SaaS provider in below that, and that is managed by the cloud provider. So this is the three tiered user and providers of cloud computing. And now we see about the types of cloud. So we have like the enterprise using the private cloud, or like the public cloud, or even the mix of both private cloud and public cloud. We call it as the hybrid cloud. So the public cloud is offered by the third party providers. It is available for anyone over the public internet, and it scales quickly, and it is very convenient. And in the private cloud, it is offered for selected users over the internet within a private internal network as well. It provides a greater security controls because it is not much exposed to many people or many hackers or like any kind of attacks possible. So it obviously gives more security. It requires a traditional data center staffing and maintenance. And then we have this hybrid cloud, which is a mix of this public as well as the private. So it has a shared security responsibility, and also it helps to maintain tighter controls over sensitive data and processes. So these are the top 5 providers of public cloud: AWS, Azure, Alibaba Cloud, Google Cloud, and DigitalOcean. And then in private cloud we have this Oracle VM, that is a virtual box, VMware, and Dell, HP, and Power Systems, and Super MICR, and OpenStack. So these are the private cloud providers. So when we mix both the public cloud and the private cloud, then that becomes the hybrid cloud. So in the next week we will see about the virtualization, and we will have a demonstration on VirtualBox, and then we will learn about hypervisor in the next week's lecture. So that's all for this week lecture. So I hope you all understand this concept. Please check on to this channel and this playlist for more videos regarding this DSA 441 cloud computing. So then I will be uploading each and every week with a new lesson. Thank you.